Well, welcome to another exciting round of Multiplying Mayhem. I'm your host, Mayhem Matt. Let's get started. Well, today's topic is on simultaneous equations, or system of equations if you prefer. Either way, you're going to be dealing with more than one equation at a time. Now, you might be saying, oh my gosh, Matt, we don't even like dealing with one equation at a time, much less two. Is there any hope for us? That's an excellent question, and as of today, I have so much hope for you. Can we bring in the hope? Well, here we go. This is Hope. Now, in all fairness, she did stay up all night explaining to me the systems of equations. So hopefully, get it? Her name is Hope, so hopefully. Anyway, I'll be able to explain it as well to you as she did to me. Wait, hold on. Okay, I just got this. We do have some footage of Hope demonstrating simultaneous equations in action. Can we roll that footage, please? Well, that's going to be pretty hard to compete with, obviously. But that being said, let's get ready to meet our very first contestants of the simultaneous equations show today. And here they are. We have got x plus y equals 3. We have x minus y equals 7. Now, when we look at system of equations, there's a couple of different ways we can work with them, right? We can use the elimination method or the substitution method. If these x and y variables were isolated, we would use the substitution method, right? X would be equal to something, and we would just plug that in at the appropriate spot, solve for the equation, and move on about our life. But that's not the case here, is it? No. So we're going to do elimination. That's right. Think about after Taco Bell, the elimination method, right? No offense to Taco Bell, love Taco Bell, been a big fan of Taco Bell. I don't know how I got on Taco Bell. Let's go back to the system of equations. So we can see that we're going to use the elimination method, right? So we've got an x plus y and we've got an x minus y. If you're noticing what I'm noticing, and I know that you are because you're astute people, we've got implied coefficients in front of the x and we've got implied coefficients in front of the y, don't we? And those implied coefficients are all together. That's right, numero uno. Okay, that being said, we want to just add these equations together since we've got a plus and a minus, right? And we kind of know why. But let's go ahead and work through this and see how this all shakes out. So let's get ready to do our operations. We all agreed, right, that we're in agreement on doing addition. So I'm going to go ahead and make this noted right here. And we're going to add these together, right? So an x plus an x gives us, well, that's just simple. That's just two x's, isn't it? All right. And we said that there's an implied one here and an implied one here. I'm going to put that in for this particular purpose so that we can say that we're saying 1 plus a minus 1. Yeah, that zeroes out. That's why we did it this way, so that we could eliminate this y. And that is just all going to be equal to what? 3 plus 7 is, last time we checked, it's 10, isn't it, boys and girls? Excellent. Well, 0 times anything, what is, yeah, that's 0. So let's just go ahead and get that 0 out of our life. I'm going to rewrite this a little bit cleaner so we know what we're dealing with. And this is just going to be 2x is equal to 10. Oh, we've seen this many, many times, haven't we, my friends? So what are we doing? Well, we're solving for x, aren't we? How are we going to solve for x? We're going to isolate x. How do we isolate the x? Well, the 2 is being multiplied to the x, so right. Inverse operations to the rescue. We divide both sides by 2. That's going to give us the x on the left-hand side. And if I do it on the left-hand side, what do I got to do on the right-hand side? Same thing that I did on the left-hand side. Done this many times. All right, now what do we have? Well, we got 10 divided by 2. What does that equal? Well, we know that. That's 5. All right, well, that's excellent. Are we done? Oh, you wish that we were done, but we are not, my friends. We've got to solve for y. Why? Well, the jokes write themselves, don't they? We're solving for y because these are simultaneous equations. We're trying to solve for two variables. So how do we solve for y? Well, that's a great question. We plug the 5 back into one of these x's. And then we solve for y. Well, does it matter which equation we put it into? No, not really. But that being said, we've got a minus here. And anytime we can avoid negativity, subtraction, or anything to do with the minusing, let's avoid that. So I'm going to plug this 5 back up into the x right up here. And then we will solve for y. Are we ready? Let's go over here and do this real quick. So I'm just going to bring the 5 here. I'm going to write it down, put it in parentheses here. And then I'm just going to write out the rest of this equation, right? That is plus y, and that is equal to 3, isn't it? Well, this is relatively simple and straightforward, isn't it, right? We're trying to solve for y. How do we solve for y? We got to isolate y, right? Did it isolate y? Why? Well, anyway, you know what I'm trying to say. We're solving for y. This is a positive. How do we get rid of a positive on the left-hand side? Yep, we subtract that bad boy. So if I subtract 5 from this side, you see where we're headed there, don't you? Right, we got rid of the 5s. Now we're left with a y. And that's what we were after in the first place. Or second place, I guess, since we solved for x initially. And that is equal to Well, it's 3 minus 5, isn't it? Because I subtracted 5 from the left-hand side. I got to do it on the right-hand side. And that is equal to a negative 2. Well, what do we have now? I'll tell you what we have. We've got x is equal to 5, and y is equal to a negative 2. How would this look on the coordinate plane? See, I beat you to the punch. I knew you were going to ask me, and I'm going to show you how this would look on the coordinate plane. By the way, I invented the coordinate plane, but don't let anybody tell you different. Here it is. So we've got our x here, a horizontal line, right? We've seen this in junior high school. I know we have. And our vertical line is y. Yep. So our point of origin is 0, and we're going to just count over 5 spaces to represent the x. And let's just say that 5 is right around here. We're going to go back to our point of origin 2, go down 2 places, right down because it's a negative 2. And let's just say negative 2 is around there. That's how this would graph. Now, we could even do the proper notation and do it like this. 5, comma, negative 2. The 5 represents our x variable. The 2 represents our y variable. Well, that's all the time we have for here on Multiplying Mayhem. Hope and I have so much mayhemming and menacing to do on the Las Vegas Strip. So we are out of here for today. But thank you. You've been a wonderful audience. We will see you next time here on Multiplying Mayhem. I'm your host, Mayhem Matt, wishing you a mayhem-free day.